Yes, is that audible students? Look at all of you. Then isobars and isotones we are discussing. Isotopes nothing but same atomic number. Isobars nothing but same mass number. Isotones nothing but same number of neutrons. Next, two more are there that are isosters. Isosters, remember, it's very important. Isosters also. The same number of electrons, same number of electrons, and also same number of atoms, same number of atoms, same number of atoms. For example, carbon monoxide and nitrogen N2. Carbon monoxide and nitrogen if you take. Then here 14 number of electrons in the both. In electron in the CO, carbon 6, oxygen 8 to 14. Then nitrogen 7 plus 7, 14. Number of electrons are 14 in both. Same. Then number of atoms equals to 2. Number of atoms here 2, then here 2. So same number of atoms and same number of electrons containing species are called isosters. Then isodiaphers also is there. Isodiaphers nothing but what? Same isotopic number. Same isotopic number. Same isotopic number containing species. What are the same isotopic number? Sir, A minus 2Z. A minus 2Z. This is called isotopic number. Isotopic number. Examples I will give to you. Such as isodiaphers example I will give. So what is the isodiapher? Same isotopic numbers containing elements are called isodiaphers. Examples for the isodiaphers are, look at uranium 92, 236. Then thorium 90, 232. So look at these two are isodiaphers I told. So A minus 2Z value should be same. Say what is there? 236 minus 2 into 92. Then even here also 232 minus 2 into 90. 2 into 90. Then you can get here 236 minus 184, that you can get, it is 52. Even here 232 minus 180, you can get here 52. So isotopic number is same. What is the isotopic number? A minus 2Z. That we are calling isodiaphers. So based on this topic, they will ask a question: which of the following sets are isodiaphers? Which of the following sets are isosters? Which of the following sets are isobars, isotopes? Such type of questions they will ask. So next topic is electromagnetic radiation. Electromagnetic radiation. So based on the electromagnetic radiation, frequency, wavelength, energy of the light, then energy of the light in number of moles, such type of questions they will ask. So here what are the constants are required, what is the formula, and how to discuss. Actually energy of light can be represented is equals to h nu. So here nu nothing but frequency of light. H is Planck's constant. Planck's constant. Value of Planck's constant is 6.63 into 10 to the power of minus 34 joule seconds. So here nu frequency is equals to C by lambda. Mu equals to C by lambda. So this is lambda. Lambda nothing but the wavelength of light. Wavelength of light. So what is the wavelength of light? So in case if you take wave like this, the distance between the two successive trough or crest is called wavelength. So wavelength this is. Then we can also write like this: wavelength equals to C divided by nu. C divided by nu also we can write. So E, it is equals to, in the place of nu, in case if you take C by lambda, so HC by lambda also you can take. HC by lambda also you can take. Based on all these formulas, they will ask you questions. So here one more, that is E equals to HC nu bar also you can take. Nu bar nothing but is a wave number. Nu bar, nu ante frequency, nu bar ante wave number. Nu bar, it is equals to wave number. So wave number, it is equals to C by lambda. So in the place of C by lambda, we can also take 1 by lambda, not C by lambda. 1 by lambda, that is nu bar. 1 by lambda, that is nu bar, wave number. So based on all these, they will ask you questions. Whatever the previous year questions are there, based on it, that we'll discuss evening live session lo వీటి గురించి ప్రాబ్లమ్స్ కూడా డిస్కస్ చేద్దాం. సో నెక్స్ట్ టాపిక్ ఈజ్ నెక్స్ట్ So electromagnetic radiation. After we have to discuss about the hydrogen spectrum and what type of questions they will ask based on the hydrogen spectrum. Already Bohr's atomic model we are discussed. Already Bohr's atomic model, you people are completely studied about it because it is there in the first year IP examination. So now we have to discuss what type of questions they will ask based on Bohr's atomic model and as well as hydrogen spectrum. So hydrogen spectrum, if you take hydrogen spectrum, is very important after quantum numbers in this chapter. Quantum numbers most important topic in this chapter. Next after which is hydrogen spectrum is very important topic. So hydrogen spectrum kanaka meer observe cheste. So I will draw the hydrogen spectrum once. Look at carefully. So these are orbit numbers. So n equals to 1, then n equals to 2, then n equals to 3, n equals to 4, n equals to 5, n equals to 6, then n equals to 7, then at last n, it is equals to infinity. Infinity number of orbits are present in it. The first Lyman series we are taking. Lyman series we are taking. Lyman series we are taking. Yes, this is called a Lyman series. Lyman series. So in the first line, whatever the line is there, this is alpha line, then beta, gamma, like that also you can define. So first line of Lyman series annadu anukondi. So first line of Lyman series. Lyman series. Next, what we have to take? N1 value you have to take 1, then N2 value you have to take 2. First line of Lyman series. Or Then we can also longest wavelength of line. Longest wavelength of line ante kuda same n1 value 1, then n2 value 2. Clear? Then shortest wavelength or last line. Shortest wavelength or last line of Lyman series. Last line అని కూడా అనొచ్చు లేదా limiting line of Lyman series. Shortest wavelength of Lyman series or limiting line of Lyman series అన్నప్పుడు n1 value 1 తీసుకుంటాం, n2 value infinity you have to take. So not only in the Lyman series, man, you have to remember Lyman series n1 value always 1. In case if you take Balmer series, look at the Balmer series. So first line of Balmer series, what you have to take? First line of Balmer series అన్నాడు అనుకోండి. First line of Balmer series. First line of Balmer series. What you have to take? N1 value it is equals to 2. N2 value equals to 3. N1 value it is equals to 2. N2 value equals to 3. Then last line or limiting line. Last line or limiting line of Balmer series only. Balmer series, what you have to take, man? N1 value 2 only, but N2 value infinity have to take. So again, shortest wavelength and longest wavelength. Shortest wavelength of Lyman series you have to take. Shortest wavelength. So wherever the last line is there, that is shortest wavelength. Then wherever the first line is there, that is longest wavelength. Longest wavelength. So this is Balmer series. Next, passion series. Next, bracket. Next, fund. This is bracket. The next, fund series. Remember. So if they will ask a question, calculate the wavelength of Lyman series of first line, or calculate the wavelength of longest wavelength of Lyman series. So how to find out longest wavelength or shortest wavelength, first line or last line? Which formula we have to use? So 1 by lambda, this is the formula to calculate. 1 by lambda equals to R, Rydberg constant, into Z square into 1 by n1 square minus 1 by n2 square. This is the formula. N1 it is equals to what? So whatever the series will be there, Lyman series n1 equals to 1, Balmer series n2 equals to 2. So like that you have to take. So first, then series of number. Then it is depends upon the series. Then n2, then limiting unit based on the from where to where transition takes place, that you have to discuss. So here, in case if they will ask calculate wavelength of limiting line of Lyman series. Limiting line of Lyman series. So remember limiting line, nothing but what I told. The Lyman series they are mentioned. So Lyman series n1 value equals to 1, n2 value is equals to infinity. N2 value is equals to infinity. So now we have to substitute all these values in this formula. Then is that hydrogen atom? Yes, in hydrogen atom you have to take. So hydrogen atom, if you take, then the Z value you have to mention it. So any other atoms like helium plus ion or beryllium plus 3 ion like this will be there. Then you have to take, it is an atomic number based. Then 1 by lambda it is equals to R into, so Z value need not to take for the hydrogen atom because Z equals to how much? 1, atomic number 1. So need not to substitute it. So then 1 by limiting line 1 square, then minus 1 by infinity, 1 by infinity is 0, then 1 by 1, then you can get is 1, then 1 by lambda it is equals to what? R. Then lambda equals to what? 1 by R. Remember 1 by R value, then shortcut method 1 by R value, that is 911 angstroms in the angstroms. Okay, the same thing in case calculate the wavelength of first line of Lyman series. Calculate the wavelength of first line of Lyman series in hydrogen atom. Calculate the wavelength of first line of Lyman series. Calculate the wavelength of first line of Lyman series in hydrogen atom. In hydrogen atom, in case if they blast. So here n1 value is 1, then n2 value is 2. Then wavelength 1 by lambda it is equals to R into 1 by n1 square minus 1 by n2 square. This is the formula, right? So 1 by lambda it is equals to R into, what will be there? So 1 divided by 1 minus 1 divided by what? So 2 square nothing but 4. Right? So 4 minus 1, 3 divided by 4. So 1 by lambda it is equals to R into 3 divided by 4. Then lambda equals to, lambda it is equals to 4 divided by 3R. 4 divided by 3R, you have to calculate like this. Okay, so such type of questions they will ask in the examination based on this. Then also calculate the radius of, also asking the radius of nth orbit, the first orbit or second orbit or third orbit of hydrogen atom. Then energy of nth orbit of hydrogen atom or hydrogen like species. So ala question ichinapudu elanti type of question, calculate radius of nth orbit of hydrogen like species. Hydrogen like species nothing but one electron containing species. Ante hydrogen atom avvochu, then helium plus, then lithium plus 2 or beryllium plus 3, whatever the ions or atoms will be there, that is hydrogen like atoms. So radius of nth orbit find out cheyadaniki Rn it is equals to 0.529 into n square divided by z. This is the formula. N square divided by z. This is the formula. Then calculate energy of nth orbit. Energy of nth orbit of hydrogen like species. Again, hydrogen like species. Hydrogen like species are what I told. Hydrogen helium plus, lithium plus 2, beryllium plus 3, hydrogen, helium plus, then lithium plus 2, then beryllium plus 3, such type of atoms. So energy of nth orbit is equals to minus 13.6 into Z square by n square. This is the formula. Z square by n square. This is the formula. Yes, note it all these formulas.